Welcome to part 9 of this demonstration of a YUI-based Ajax application being developed using EWD. In part 8 we'd reached this point where we had a library catalog dialog panel with two embedded layers of tab panel widgets, inside of which is a form asking us to search the iTunes database by artist. We're actually looking here at the original working application that I demonstrated in part 1. So let's remind ourselves what's supposed to happen if I enter an artist into this form. So let's add brand X and press query, and back come the results presented in a nice YUI data table widget that's not only paged but also has sortable columns. If we look at where we'd actually reached in part 8, which is this tab here in Firefox, we have the form, but if we click the query button you'd find that nothing would happen. Why is that? Well, if we look at the fragment containing the form, which is this one here, you'll see that the submit button just contains a name and value attribute, but nothing else that would tell the fragment how to tell the form or the submit button how to fetch a fragment and where to put it. And if you remember from the login form, you would do this by adding a next page and target ID attribute into the YUI submit button. Now we'll start to build all of that out into this fragment in the next part, as part 10. But at this point I'd like to digress a little bit and look at the database that we've used to contain the iTunes track library. Now I could have used any database that's accessible from Python, but because we've been using EWD in an instance of the MDB appliance, it makes sense to use MDB as our database. So let's take a closer look at MDB and how you can access it from Python. Because MDB is such a close emulation of Amazon SimpleDB, we can use the standard recommended Python client for SimpleDB, which is something known as Boto. Actually, let's go over to the browser here and show you where you get that from. If you go to the Amazon Web Services site and go to Amazon SimpleDB and then look in the section Sample Code and Libraries, search through the list, you'll find this thing here, Boto AWS for Python. And that's what we're going to use in our example behind the scenes. I've already installed it on my MDB appliance, so if we look over here in my PuTTY session on my MDB appliance, then let's have a look at how we can manually run the query that we demonstrated in our application. So the first thing we need to do is go into Python, and then I say import Boto. And now at this point we can use the standard connect SDB function in Boto, but it usefully, and I'm going to paste it in here, it usefully allows us to make some modifications. These aren't modifications I've made, they're standard overrides within Boto. So I can define the path, and this is the MDB path. I can override the security, so instead of using default SSL I say is secure as false, and here I'm defining the IP address of where my MDB appliance is. And if I click that, now we're connected to MDB. So now we're going to run the query. Let's define the query. So we can say query equals select star from iTunes, which is the domain name or table in MDB where I've got my data, where artist equals brand X. So that's our query. Now we're going to run it. We'll return the results in something called items, mdb.select. We've got to tell it the domain name and then the query. And now we can look at the items that it's found, and here we go. So you'll see that the results are returned as a Python dictionary. Note that it's in Unicode format, represented by the little U in front of all the records. Here's one record that it's returned, the last one in this case, and each record actually in simple DB parlance is known as an item, and the fields, the individual fields that make it up, are known as attributes, and they're such things as album, artist, composer, play count, and so on. So that's how we can retrieve our data from MDB, and in the next part we'll look at how we can invoke this query from within our EWD application, and how we package the contents of this response dictionary into our YUI data table. So see you in part 10.